Okay, working our way through. We're talking about parametric polymorphism, and you ought to be able to guess that it's going to have something to do with parameters. Um, so we say that a function has parametric polymorphism. It exhibits parametric polymorphism. And I'm going to say these words, and it's going to be frankly a little bit confusing, and then I want to back up and walk you through it. Okay. The function exhibits parametric polymorphism if it has a type that contains one or more type variables. You're like, what are you trying to say? Okay. And the easiest way, and I'm going to come back to the slide, okay, easiest way is to show you an example in ML because it was actually ML in what, 1975, that introduced the concept of parametric polymorphism to the world of programming. Okay. So here's the classic, right? The classic ML. So here we go. I got a function. This is the part that I'm typing, and then the bold is the part that SML is responding back, remember? So I declare a function identity, which takes an X and delivers an X. And then this whole comma A thing, or what is that? No, it's not a comma. It's an apostrophe. Apostrophe A. I take an apostrophe A. I deliver apostrophe A. Remember what that means? It means anything. This is parametric polymorphism, okay? Kind of just native in the language. It's just the way ML rolls with anything that I don't say up front. And ML doesn't care. You know, it just, as long as they're consistent, it wants consistency, but in particular, it doesn't really care. So and all identity does is take something and kicks it back. So, that's just showing me the type. Then I go identity 3, it goes 3. I go identity hello, oh, it is hello, and it's a string, by the way. As ML does, like, yeah, 3, yeah, that's an integer, by the way, right? And it's just fine with that. And so, going back to this thing, the notion that I have a parameter that has more, one or more type variables, just meaning, I don't like it because you got type and variables, and it's munging the words. What we're really trying to say is that I've got a type in the parameter that can be multiple things, is really what that's trying to say, okay, as I pass it in. So when I call identity 3 or identity hello, okay, that parameter can be, any type that's supported, right? So hence parametric polymorphism, the parameter list can be just varying types, all right? And then one of these types that can be anything is called a polytype. So that apostrophe A is a polytype, okay? And then number of languages, right? Most natively in ML, as we're kind of seeing. And then here's another one, right? I got a function called reverse. If it's, I don't care about the details here, right? Other than the fact that having defined this thing, I've got, I create sorry. ML is saying that the value of reverse, after I did all that, it goes, value of reverse is a function that takes a list of somethings and returns a list of somethings. And again, doesn't care. Now let's contrast that, okay? So we said that C++ supports this. Yeah, but look at the work, man. Look at the load. Okay, so this is just the syntactic sugar. Okay, this is what you have to do for C++. You say template. You say, less than, open bracket, right? You say class, and then you define a type, something that's going to represent the type inside, the parameter list and in your code. But that's just a type. I don't know what the type is, and that's my way of saying that. Template, bracket, open, whatever that is, greater than, less than sign. Class, my type, close that. Then I'm going to say that max is a function that takes a value A of my type, a value B of my type, and returns a value of my type. And I don't know what it is. You see that it's the same as ML, but I don't know what it is. All right, and then this is the code, right? I return basically whatever this evaluates to. And what this does is it goes, this is the syntax here in this ternary operator, if you're rusty on this, is A greater than B? If it is, then return A. If it's not, return B, right? That's the ternary operator. It's essentially a compact way of doing an if-then-else statement. Then later on, I've got this function G, and it got in there with an A and a B that were integers, and C and a D that were characters, right? And then I declare M1 to be an integer, and he's equal to the maximum of A and B. And then I've got M2 to be declared a character. He's the maximum of C and D. Well, C and D are characters, A and B are integers. So I get these in with different types, and then when I make my call, then the compiler, the compiler resolves all this stuff basically with overloading for the most part, but some of the tricks that we've already talked about. And then keep in mind that this greater than sign, you're like, wait, what about strings? What about other things in this my type? Well, remember that you can overload that operator as well. You can overload that guy. So as long as anything I can overload that operator to be, it's going to work in this thing. Okay. So how do you implement it? And this is, by the way, our last slide on parametric polymorphism. How do you implement it, right? And so there's really two extremes, and the first extreme is you build many copies, and what that means is it's like a little bit like we talked about with overloading, where you've got a bunch of monomorphic implementations, and monomorphic, again, remember meaning only one type. Okay, so I'm going to basically create one version of my code that works on when it's an integer, another version when it's a character, and I'm going to just duplicate all that, right? The other extreme is I just make one copy and then I use other kinds of language tricks to make it work, whether that's coercion, other kinds of implicit whatever, but I can't optimize for individual types when I do that. So anyway, a lot of approaches and pretty much everything in between, but you ought to understand the concept of parametric polymorphism actually pretty intuitively right now. And I want to just back up for a second because of ML. What we're getting out of this ML experience is a really comfortable familiarity with this idea that I've just got lists of stuff and other lists of stuff, and I don't care, right? And whereas in C++, if you first learned about, I remember, when I taught C++ a lot of years ago at BYU, and I remember that polymorphism was like a topic we hit, like in week 12, and this was the big C++ class where it was kind of the sophomore level big projects. This is where you're going to kind of pony up and be a real programmer kind of thing. And I still remember it was just a topic that came late. Well, look at all the syntactic crap you have to do to make it work. There's a lot going on. Now, here we are. I understand it's a senior level class, but I could give this to, anybody that I was learning, somebody learning the program in Python right now, and just do ML instead. And then you just told them, yeah, see that thing where that comma A, yeah, I don't care. Sorry, not comma A, apostrophe A. And then it just returns apostrophe A, and you're like, what does that mean? It means I don't care what that is. It can be anything. They're like, oh, yeah. I mean, they already know the world's like that. I got a bag, from the grocery store. I can put milk in it. I can put eggs in it, right? Yeah, and I don't care what I put in it, as long as I can stick it in my grocery cart or get it in my car and bring it home. I mean, that's a natural concept, but it's just taken a long time to work its way into, kind of conventional popular programming languages like C++. And then by the time it did, it was in this kind of grungy form because the native approach of doing it was already kind of like had a meaning, so you had to go create these other mechanisms behind the scene to go do that. So that's kind of the basic idea there. And so naturally, and as always, there's a lot of different mechanisms in between, but you ought to understand the notion of having the parameters themselves be polymorphic in the sense that I don't care, what type they are. Okay, that's it for parametric polymorphism. What we're going to do next is subtype polymorphism, and this is the last sort of major subject area of Chapter 8. We're coming back to that one in the next podcast.